napindot ko tuloy, tapos na-end ko, minus 32 yung trophy ko. Nag-iipon ako. Tapos check lines. Kanina, bigla mo akong pinausap. Napindot ko. Hindi dapat ako maglalatabi.
Saan?
Doon sa tutor ko yun.
Guys, good morning. We'll be starting our presentation on the study of sawdust ash as admixture in the strength of concrete under prolonged curing. So before we start, we would like for you to take note of our three samples in front of you. One is our sample of plywood, which will be discussed in methodology. Our sawdust ash, which will also be discussed in methodology, and our sample mold, which will also be discussed in methodology. Okay. Our greatest concern here is the environmental impacts of the construction industry, particularly in the timber trade. It's the depletion of resources and high waste related to the timber industry. So for sawdust, in one study, it is found that around 5 to 12% of the raw wood becomes sawdust. And this translates to, and the global timber industry trades around $150 to $160 billion of wood each year. And that translates, the sawdust translates to $7.5 to $19.2 billion. So what we're looking at here is that the Philippines produce around 81,000 tons of sawdust every year. This will be shown more clearly in the RRL. But for now, the group projects that this 81,000 will increase because of the master plan for forestry development by the UN and the two executive orders 23 and 26, which will expand the number of forestry that we have. Next, sawdust ash. Sawdust ash is a product of burning sawdust. It's one of the most common choices for sawdust plantations to do with their waste sawdust because it reduces greatly the volume of sawdust. That will be discussed further in RRL, but I'll mention it now. It's around, from 100% volume of sawdust, it can be reduced to around 2% when turned to sawdust ash. And sawdust ash is also an alternative fuel in rural areas to cook food. So the group would like to conclude that sawdust ash will definitely exist where sawdust exists. And for our significance of study, Ms. Villagan.
For the significance of the study, a study of sawdust ash as an admixture on the strand of concrete under prolonged curing will determine the efficient percentage of adding SDA or sawdust ash into the mixture that will yield the maximum compressive strength. Also, this study will include a study entitled Influence of Sawdust Ash as Admixture on Cement Paste and Concrete by Egri Aubert and Ayala Solomon by decreasing the range of additional SDA into 1%, 2%, and 3% by weight of cement. By this, we will be able to get or determine the maximum percentage of SDA that will give us the maximum compressive strength. And also, this study will be very significant to engineers and contractors if they want to use the result of our study, which is the sawdust ash, into their projects or residential houses. Because by using sawdust ash as admixture will divert the environmental problem into an efficient way of using or disposing the sawdust ash. The main objective of our study is to investigate the sawdust ash as admixture on the strand of concrete by recording it. And we also aim to determine the pozzolanic classification of sawdust ash. What we mean by determining the pozzolanic classification is we will see if the sawdust ash we acquired is or pass the ASTM C618, which will be discussed in the RRL. And another one is to determine the effect of sawdust ash on the setting time of the mix. The third one is to determine the maximum percentage of sawdust ash that will give the most increased compressive strength. Scope and limitations. In this study, we will be going to use commercially available plywood, which will be from the burning of sawdust ash using a metal container, which will be discussed thoroughly in the methodology. We will be adopting British Code of Practice of 114, 1:4 weeks, considering 2,500 to 4,000 ASI compressive strength. And the purpose of this study is for one to two floors residential houses only, with a cement ratio of 0.4 to 0.5. And for our conceptual framework, of course, the input is composed of basically the water, sand, gravel, and admixture, and our sawdust ash at 1% to 2%. The process will be, the first one is we undergo chemical analysis of sawdust ash, which we pass through CTC or cement testing center. And the mixes are 1:4, one cement, 2 sand, and 4 gravel. Plus our additional percentage of sawdust ash. And the test will be compressive strengths at 28, 50, 100, and 150 days using universal testing machine and aesthetic times. The output will be the physical and chemical properties of our sawdust ash, specifically the lime and the silica. The compressive strength of concrete at 1%, 2%, 3% under prolonged curing, and the setting time of concrete with SDA. And for the review of related literature, Mr. Charles Yu will be discussing it.
So the first focus in our review of related literature is the timber trade. How large is the global timber trade going on? As I mentioned, $150 to $160 billion with a growth of 4.5% every year, and that translates to 635 billion cubics of wood. For locally, we have been an exporter of lumber in the 1980s. However, by the time 1990s came, we have imposed a log ban throughout the country. However, log imports are liberal, and thus our sawdust mills are continually functioning. And recently, the private sector has been invited to utilize our forest lands. So, I have mentioned earlier that the Philippines produce 81,000 tons of sawdust. And we project this, it will increase because of the Master Plan for Forestry Development and Executive Orders 23 and 26. So what is the Master Plan for Forestry Development? Ma'am, should we wait for a moment? Okay lang. So Master Plan for Forestry Development is a plan implemented by the United Nations to increase our forestry base and to increase the efficiency of lumber mills throughout the country. This has been implemented since 1991 and will end this year, 2015. So recently, Executive Order number 23, signed by Benindo Aquino, has invited private firms and local communities to utilize forest lands. And EO 26, which National Greening Program for Philippines, they aim to plant 1.5 billion trees in 1.5 million hectares in 6 years. So sawdust to sawdust ash, I mentioned this earlier, that just by burning it at 350 degrees Celsius, your 100% sawdust volume can be reduced up to 2%. This is a separate study done by others. So what this means, it's a popular choice for lumber mills to do to reduce disposal costs, especially if it's per truck. So what are the hazards of sawdust ash? Sawdust ash can be very leachable in large quantities, especially if left in an area. It can be blown away and it can be absorbed by the local fauna and flora and have an environmental impact. And since the components of sawdust ash is very alkali in nature, it can damage organic tissues such as skin or lungs when inhaled. So what are the common management of wood sawdust ash? The ash can be used to stabilize the soil by increasing its bearing capacity and balancing its pH, especially if it's acidic. Number two, which is our focus, is to add it in concrete to help with the strength and the flow. So other studies on sawdust ash in other countries is partial replacement for cement, especially in large countries such as Africa, China, where sawdust ash is very, very more abundant compared to the Philippines. Some studies have been partial replacement for fine aggregates, and our focus admixture. And for the rest of the RL, is Justin Desas.
So what will be on the sawdust ash to consider as admixture? Sawdust ash has four components. It is silica, aluminum oxide, iron oxide, and lime. And this four is based on the ASTM C618. So, pozzolanic capability of sawdust ash. There are three classifications of sawdust ash: Class N, Class F, and Class C. Class N is a calcine. Class N is a calcine raw material. Calcine means superheated. Class F has a pozzolanic properties and came from bituminous coal. And Class C, where sawdust ash belong, because its pozzolanic properties is based on cementitious material. So, relationship of chemicals. Our focus is in the silica and lime that the sawdust ash has. So, once the sawdust ash has a high silica and lime, it gives high compressive strength. So, why we choose sawdust ash as an admixture? Since sawdust is 81,000 tons, it cannot replace cement. So, we use sawdust as replacement, as admixture. So, similar admixture is the silica, fume, and thin lime, which also improves the strength and the compressive strength of concrete and mortars. So, our thesis proposal is admixture, sawdust ash as admixture under prompt fueling 28 days, 50 days, 100 days, and 150 days. In other study, they use sawdust ash as additional in soils, and softwood ash and hardwood ash. This is the properties of softwood and hardwood ash. Since we use both softwood and hardwood, we disregard its properties. In the figure, as the sawdust ash increases, its setting time also increases. And in this figure, as you can see, as sawdust ash increases, the compressive strength decreases. But in the 2%, it gives a high compressive strength. So we use 1%, 2%, and 3% of additional sawdust ash in concrete and compare it to the result of this previous study. And for the methodology will be discussed by Tuesday.
So for our methodology, we'll be using an experimental design. Since we have two values that we need to get. First is the compressive strength of concrete with and without the sawdust ash and with varying the mass of wood. Second is the setting time of the concrete with sawdust ash. So first, for our use composition, we have chosen cement of like what Portland cement. Since the target of our group is a residential building, we'll just be using a type of Portland cement. For our water cement ratio, in our paper we have written 0.6, but Ma'am Chris Mantanilla noted that the water cement ratio when using a bagger is reduced. So we'll be initially using 0.5. However, if the trial mix didn't pass the test, we'll reduce it to 0.4. Nice. So for our sand, we'll be using river sand for our fine aggregates. We have done preliminary tests that comply with ASTM C127, C128, and C136. For our river sand, we found out that the specific gravity is 2.63 and the finest modulus is 3.115. And for our gravel, we'll be using 3/4-inch gravel, the commonly used gravel for residential buildings. And for the SG, we have found out that it was 2.78. And for the sawdust ash, so we know that sawdust ash, or commonly known as basalt in rural areas, can be used for different purposes. However, in here we want to use it as an additive for our concrete. For burning the sawdust ash, we have chosen to use the Fulgora burning stove concept. Fulgora burning stove is used in Europe for burning sawdust ash. However, we have simplified the concept by using a can for oil, the square one. And we have placed a hole on the side and on the top of it. In the next pictures, we'll be showing the process for burning the sawdust ash. So first, this is the plywood that was used for obtaining the sawdust ash. In the table, you can see the plywood. Please note the varying color for the plywood. The varying color indicates the different species used for the plywood. In our earlier RL, we have said that even though the species are different, it doesn't affect the properties much because there is little difference between hardwood and softwood when already burned. Next. And this is the sawdust collected when after the plywood was used. As you can see in this picture, we have placed two pipes. Actually, one is a bamboo, the other is a PVC. These two pipes will serve as an air shaft for the flame to burn properly. And for the sawdust ash, you can see that the sawdust was compacted before being burned. So, the sawdust was compacted for two reasons. First, for safety purposes. We don't want the sawdust to fly when the fire was burning. Second, we compacted it for efficiency. Since mixture portion for residents. For our mixing, as I have mentioned, we will be using a one-bagger mixer. For casting and samples, at first we decided to use 6x12 casting mold. However, due to limitations in the lab, we have to use an alternate mold. As you can see on the table, we have provided a PVC mold. According to an ASTM article, it is allowed since the difference between the strength of the mold of the 6x12 and the 4x8 is the difference is negligible. So we'll be using 3 samples per mix per testing day. And for our schedule, as you can see, we started burning sawdust from March 30, and a portion of this sawdust was submitted to the CTC or Cement Testing Center in Pasig for chemical analysis. This chemical analysis is needed to know whether the sawdust ash complies with ASTM C618 and what post-granitic classification costing. And on May 2, we have procured the cement, sand, and gravel that will be used. And on May 6 to 8 and 11, we have done the preliminary test for the gravel and sand. If allowed, we will be following this schedule for our mixing, casting, and testing. On May 25, we'll be actually receiving the results for the SDA. And on June 8 to 12, we will be evaluating the trial mix. After 150 days, we'll be testing the mixes on probably December 2015 if there are no delays. And these are projected costings.
Ilan sila bill speaker?
Oo nga. Congratulations. Para ako nagkakaroon, nasa ka naman sa parang kliyente. Depending their product. Congratulations. I can see your bright future. Parang galing yung mga convince.
Oo nga.
The way you present your paper. So yun lang, parang maano ka na makinig. Pero, this is my own questions. Can you please convince me? Actually, this topic is already existing, as you have said a while ago. There are a lot of studies regarding this matter, not only in the Philippines, even in other countries. So can you please convince us more? Why do you choose this topic, and how does it differ from those existing research?
So, ma'am, when we mention the other studies pertaining to sawdust ash, the majority of our RRL are focused on replacement for cement. These are in China, India, and South Africa, where lumber is really used abundantly. So they use replacement for cement because of the abundance. We only found around 1 or 2 for admixtures. So we saw an avenue where there is not much research, and we took that path, especially in the context of the Philippines, where the sawdust and sawdust ash is more limited compared to those countries.
And why we choose it as an admixture? Because
For a while, extend ko lang doon with regards dun sa what is the result with regards dun sa replacement?
Replacement, at certain levels, around 5, 10, 15, it has significant growth.
Growing.
However, beyond that, significant decrease.
The compressive strength.
Compressive strength.
But in our study as an admixture, what I mentioned a while ago, the variations of sawdust ash is and the influence of sawdust ash as an admixture. They found out that at 2% of sawdust ash, it will give the highest compressive strength. What we did is that we reduced it into 1%, 2%, 3%, just to know if ever that it's not 2%. What if it's in 1% or it's in 2%? That's why we decided.
So in other words, since you're focusing on admixture, so based din sa page 34, it's more on improvement of that previous research. Is there any statistical computation with regards dun sa analysis nyo o why do you choose 2%? Tama ba? Kasi previously, it's 2468 and then based on the result, 2% is the optimum. And then kayo, you just simply
0, 1, 2,
0, 1, 2, 3, just to identify if it's
either exactly at
1,
2%
2, or 3. Because the increment of their study is 2%. What if it's in 1, 2?
by the way, what is 1%? 1% of
Weight of
Weight of cement. Minus ash.
Weight of cement, yun yung sawdust.
Yes.
Pero ano na, wala kayong statistical computations. How do you get this percentage? So assumptions lang siya from this data. Is there any previous study dito sa kanilang, hawak niyo ba to? Yung kanilang paper na to? So foreign pala to, no?
Ito po. Bali wala po.
So, paano locally wala kayo?
Wala po. Kaya po pinch po namin. Yung iba po kasi ginamit nila yun mga sa CHB.
Lasal ako
Lasal po yung ginamit ko. Bali, ginamit po na iba sa CHB po.
Tuloy lang naman yung ano ko dito. Tapos the rest, procedure will be almost the same. Or exactly the same. Will you change any procedure?
Yung days lang, days. We will
Kasi
see.
yung previous study, 210 po yung pinakamatagal nila.
Hindi.
I think 56 lang.
Oh, 56.
56 days.
Hmm.
So kayo,
Beyond 28.
so nag-extend na kayo beyond 56 days?
Pero we will be dropping 7, 14, 21.
So, focus on that.
Prolong.
Why are you prolonging the
Because
curing time?
it's pozzolanic. Pozzolanic will mean a late strength, gaining sila, late strength.
So why don't you include it in your study since you are investing time for that as well as money? Why are you, include that in your research? Kasi di ba, as you have said, you will just focus on 7.128 results. Pero beyond that,
They will be focusing beyond.
As in prolong talaga.
Prolong.
paprolang niya pa, so kunti consider niya rin yun.
Hmm.
So part of the, ano mas objective
Pero
ba?
hindi talagang sa amin kasama 7, 14, 21. Yung 28.
Kasi so beyond kayo,
Because ano nag-study yun?
kasi accepted na yun.
90% ng persistence.
Siguro yun.
Talagang mababa yung
More creative than that.
makagalan, hindi mababa.
Probably, you could just highlight that in your, nabanggit ba? Ayon sa main objective, under prolong.
Based on bacteria.
Matagal na yung tanong na yung na-improve nila yung techniques.
Pero actually, ang disadvantage pag nabasa.
Nabasa.
So yun, highlight mo yung very good.
Yung back. Pero kailangan mo rin kasi siyang basahin.
Yun yung bacteria.
So, I'll explain. Isa na lang ito pa. With regards dun sa British Standard Code na 124, up to 4,000 PSI.
Range.
Range lang po
Yeah.
is 2,000.
So the maximum is 2,000.
Yes. Per sa din.
So why are you limiting to story?
That's the
Why do you need to include this statement na for residential structures that are 1 to 2 story located in rural areas?
Context po of the Philippines. Lumber plantations and processing are more common in rural areas, not in metro, not in urban. So the abundance of sawdust and sawdust ash.
So you're talking about the applications of your product, limited for that.
It's more probable that it will be applied there.
More probable.
Teka lang linaw ko lang sa inyo, lalo na kayo nag-research. Yung dalit yung scopes and limitation, yung more on sinasabi nyo is more sa implementations na live. Hindi ba meron study, di ba? When you say scope and limitation, it's more on dun sa
Sa gagawin mo.
gagawin mo. So it's not on, kasi pag accepted ka na, fine, kung galing sa ibang bansa kasi or sa ibang place. Very important na, even ito, ating, ang lightweight will consider as a lightweight material, sawdust, pwede yan. So, kung accepted, if ever this product will be accepted, so hindi lang sa rural areas, mas magiging significant.
Basta residential, whether urban or rural.
Actually, kung 4,000 nga, kaya nililinaw ko, even 4,000, it's okay for a building. So, may mga portions sa building na we are using 4,000 PSI. 2,000 to 4,000 PSI. So, I really suggest na huwag na lang itong isama sa scope and limitation. Sa scope and limitations. Ayun, yun sa akin na. Okay, thank you again. Congratulations. Very amazed with
I
your
know we have one question.
Methodology na
Eh,
talaga,
Yes,
ito lang, kasi we have 3 options kasi because limited nga yung cast sa lab.
Sa laboratory.
So, one option is 100% gagamit kami ng PVC. Like this, 4" by 8". Kasi we'll be using 60 specimens for this. 29 lang nasa laboratory. Number 2 is 29 na metal cast we'll be using, then the rest supplemented by PVC. The third is, hanapin muna natin yung setting time. Kung nag-harden naman, within maybe 5 hours, pwede namin i-recast sa pang beses yung metal cast. Pero then again, hindi rin aabot kasi 29 times kulang pa kami ng dalawa. So, okay lang ba na either pure or halo kami?
Pure PVC.
Pure PVC for molding.
ako meron pa kanina. Okay lang naman ko. May epekto ba yun? Kasi lang
siguro,
naman
pero
yan. Kasi
mas maganda na lang na tingnan. Oo, para siya. May variation sa strength. Although kasi standard naman yung size eh.
I think wala eh. Kasi asap ng mold. We're implementing different kind of molds. So it means cover lang naman siya. So basta you done it properly.
For uniformity, parang ganda lang.
Uniformity.
Kasi iba na yung size ko. Iba na yung orientation positive.
Ilan lang? Ilan lahat ng samples?
60.
Oo, pizza na naman po.
Para pa
sample per person per...
dagdagan niyo yung samples. Tatlo lang eh. May...
I think,
Yun sa procedure.
Lang, extra lang.
Yeah.
Mga daw. Dapat 5 daw.
Ay, tatlo. Hindi ko lang. Nawawalan sila.
Hindi ko may nag-produce last time.
Ano?
Tatlo lang.
Laging fill.
Sobrang pa sa ano nila.
Sir,
Pwede
we have reserved 12 samples for this.
3.
Ang di nyo ang diniscuss sa methodology niya, yung statistical na naman, with regards sa how would you relate yung mga values na sa dulo. Hindi ko nabasa kung paano nyo i-relate.
Wala na kami, recording lang kami.
Kinuha mo siya agad ng
Graph.
Graph lang, okay lang gagamitin. Kasi marami kayong choice na dulo. Yung significant na values
long
na
terms.
pag-aralan niyo siguro yung part na yun ng analysis, interpretation of data. To think na, especially yung time, variation ng time na yan, yung how does it affect yung growth niya. So, kailangan ng statistical
Yun nakalagay sa standard.
na interpretation, statistical interpretation.
Hindi mo naman magagawa. So, mas maganda na yun kasi magiging mas conservative.
Okay? Uy, okay na ako. May klase ako. Sige. Good luck. Congratulations.
Ma'am, yung snacks.
Score?
Oo.
Ano ba yung score ko? Parang wala magaling na. Honestly, ano ba? Minakatawa ko rito na. Kanina sasabihin ko sana yung tenses, but masses. Yung pala talagang nagawa na, yung schedule niya. Grabe. Diba? So, parang sa yung common cases eh. Kaya yung pinakamagaling eh.
Hindi.
Sige po. Ano kasi umalis mo?
Anong may kayo?
Umuwi kasi ako.
So, ano ko doon? Naligo ba yun?
Hindi ko naligo.
Baka ano sa akin nga? Gilas, di ba?
Kasi ano,
Oh,
naging
hindi pa yung
siya,
first
naging
week.
sa Sir Nolan.
Pumunta daw siya dun sa pinsan. Okay.
Kasi, yes, sorry. Kasi fluid. Kasi ikaw, nung paalis ako, nararamdaman ko pagising ka niya.
Kasi narinig
No, for example, umalis ko.
Pakinote na lang. Yung sinabi ko wishes. Ako hindi klase lang.
Plus 5%.
So ba, hindi ko ako yung toothbrush ako. Bumili muna ako ng dito.
Ano to? Bini-video din tayo.
Yeah.
Iwan ko na, nag-dream mo, may klase lang ako.
Thank you, ma'am.
Tanong na, bahala na kayo siya.
Snacks nyo.
Padala na lang sa ano, pang-dream.
Sige.
Salamat.
Wait, ibang angel. Sa mga ikaw na muna.
Sa objectives.
Kapag nazozoom siya.
Yung letter C, number 3. Determine the maximum percentage of sawdust ash that will give the most compressive strength. So, based on your scope and limitations, you're only restricted to what percentage?
1, 2, and 3.
1, 2, and 3. So when we say that you want to determine the maximum percentage of sawdust, you will have, or you have to do every percentage with very huge range or large range of percentage. No addition of sawdust. So because you want to determine the maximum percentage, so you must not be restricted to 1, 2, and 3 only. You must determine at what percentage will it give the maximum value for the compressive strength. Yun yung ibig sabihin niya. So it is not, hindi siya equivalent to, dahil pinakamataas yung, for example, 2% or 3%, that will be the answer for your third objective. The true meaning of that, determine the maximum percentage is, you must determine the true value or the true percentage. At what percentage no addition of sawdust will yield to the maximum compressive strength also. So since you are restricted to 1, 2, and 3 only, so maybe you should revise that third objective kasi medyo ano siya, visible naman siya to the to your true objective.
Pwede na lang maximum percentage with the given percentage that you have. Yung range nyo. Hindi yung parang you are looking for the optimality.
Because sir, we based on a study, sir. The range you studied is at 0 to
Meron
4,
na.
6, 8. Then,
So meron na silang
the
parang...
result of their studies that the maximum
Pero-
is at 2%.
Tapos niliitan nyo na lang yun.
Yes. To ano?
Doon lang din sa range na yun.
Oo.
Hindi niya sinabi kung at parang kung i-graph natin siya, hanapin natin pinakataas. Tapos after nun, meron ng drop.
Oo.
So yun kasi ibig sabihin niya.
So kung yung sample space yun, focus dun sa pass.
So i-ano natin, i-fit natin siya dun sa true objective niyo. Yung study.
Kasi broad pa ito yung maximum percentage.
And then dun sa main objective, pwede bang ulit. At eto, binili niyo commercially. And then,
Meron yung mga pinaghatian, may puso siya, kinulit natin.
We collected the sawdust ash.
will it be different if we use yung actual sawdust of from lumber mills talaga.
Meron.
Yung mga
Kasi yung plywood, meron yung treatment either kiln dry or air dry. Basa yung fresh.
So, anong dapat specimen?
Dun sa previous studies, what are the specimens that ginamit nila for
They
sawdust?
didn't mention hardwood or softwood. Unclear din minsan kung from fresh
Or
or processed na.
Basta,
Iba-iba.
But yung 81,000 tons na binibilan nyo kanina, that is from what? Yung process or yung
Mix na yun.
total?
From round wood to finished product, lahat ng sawdust. Then basa.
So, limited na lang talaga sila. Parang limited na sila sa the nature nung tinanggal yung dust. Ano, treatment pa. Pag sinabi admixture, ano yung objective ng pagiging admixture?
Kasi ano based on your title, a study of sawdust ash as admixture.
Anong gusto mo bakit lalagyan mo siya ng
What will be the effect? Ano yung
As admixture po, it will give more
so tataas na.
compressive strength.
Okay. So,
And
ibig sabihin,
And that's all.
So dapat effect of sawdust ash as
admixture to the compressor.
in the increase of strength. In the increase of strength. And for the setting time, ano yung objective for the setting time?
objective sa setting time. Meron setting time.
Hindi, gusto niyo ba pag-ibigin?
Okay, retarder siya.
Retarder.
Meron siya previous study dito.
Cement yun, di ba?
Retarder.
Oo.
So,
So yung pagiging admixture niya, ang i-address sa strength and setting time.
Yes.
That's why we use
Yun yung title daw.
ano? Effect of sawdust ash as admixture of the strength, increase in strength. And
Yun nga.
setting time. Ano yung study?
Oo,
Study.
Oo.
Study.
Oo. Analysis. Using, gano'n. Cliche na siya.
Tapos yun sa method of burning.
Method of
Is there any ASTM designation for
Gaano katagal.
gano'n katagal? Kaya na rin yung 350 degrees. Meron.
Meron.
Pero
separate study kasi yung 350 degrees. Hindi.
Basta sunog, tapos.
Sunod.
Tapos pag nabot niya po yung gray or white.
Pag umabot siya sa ganito, sarili na siyang mamamatay. Pag umabot siya ganito,
okay.
sarili na siya.
Nag-iisip pagpatay na yun yung pinakasunog.
Yan na, wala na siya.
So yun ay pwede na siyang gamitin. In terms of column, no, yung chemical property, kasi nakita ko, large percentage of the content of gas is silica. Silica, which is 64 ata. Ano yun, 64%.
Sa ano yun? Concrete, sir. Yung Portland cement mismo.
Hindi sa...
Ito, for comparison. So, titingnan namin, Portland cement as binder, meron siyang silica 21% and lime 60%.
Ay, hindi sa
Hindi pa po. So, we're gonna titignan muna namin yung classification niya ng F or C. Titignan namin yung silica and lime. Yun kasi rule of thumb para lumakas siya.
Kasi bawal yung talaga na mag-exceed. May minimum amount kasi ng silica content na pwede mo ipasok. Kasi it will yield at so-called silica reaction. Alkali silica reaction. So, deleterious yun. So, I even, test nyo rin.
Meron na po. Palabas na yun na siya sa
chemical
Then you will classify kung silica or not.